So when we're talking here about simple molecular covalent coupled physical knowledge, we know that they do not conduct electricity. So that means it can't be C and can't be D because they both conduct. And we also know that simple molecular covalent have low melting and boiling points, which mean it is option B. A is not right because that has a high melting and boiling point. Okay, production of ammonia. So it's nitrogen, remember nitrogen is diatomic, plus hydrogen, also diatomic, and then your reversible arrows to show it's making ammonia. And then what we have to do is count the number of elements on each side, number of atoms on each side. So here we've got two lots of N, two hydrogens, and then we've got one N, and we've got three hydrogens, so it's not balanced. So what I'm going to do now is put big numbers in front of this. So to get my N's, so they are 2, I'm going to need a 2 there, which gives me 2 N's and 6 hydrogens. To get 6 hydrogens here, I'm going to put a 3 there, which takes me to 6, and there we have. Okay, so we're going to draw a molecule of oxygen. Because it's a covalent substance, we are only interested in the outer electrons, which in this case, there are 6 outer electrons. So hopefully, we're starting to remember what these structures look like. You can work it out as well yourself. I'm going to do one of these with dots and crosses. It's got 1, 2. Now it's going to be 2 electrons shared from this one. And do these ones as dots. 1, 2, 3, 4, and then it's got 5 and 6. So that means there are 4 electrons inside the bond, which means there are 2 covalent bonds in that structure. Okay, in this question, we've got 3 substances, all carbon-based, so diamond, graphene, and fullerene. And what we have to do, just to help us get into this, is we have to explain, in terms of structures and bonding, the relative melting points, strengths, and ability to conduct electricity. Okay, so let's go through each one of these. First thing to say is that all 3 of them contain carbon atoms, and they contain single covalent bonds which are strong. If we then pick up the first one here, which I'm doing diamond first, so each carbon atom has 4 covalent bonds. This gives it this giant covalent structure. It has a very high melting point because there's lots of strong covalent bonds which require a lot of energy to break. And this structure is a strong structure because it makes it very rigid because each carbon is bonded to 4 points. So here, these are the bullet points I need to include in my answer. Next one in the list was graphene. Graphene here we've got contains each carbon atom contains 3 covalent bonds. That means there are delocalized electrons. That means these delocalized electrons are free to move, and that means, not written on there, but we'll put it in there, it will conduct electricity. Okay. The other thing we've mentioned here is that it has a high melting point because it contains lots of strong covalent bonds which require a lot of energy to break. The last one is fullerene, and here I've drawn a second molecule. So that's my first molecule, and here's my second molecule. And in between these 2 molecules, there are weak forces of attraction. So this one is molecular. Again, each carbon in here forms 3 bonds. The melting point for these is very low because there are only weak forces between the molecules, and that means they don't require a lot of energy to break. These are poor conductors because the electrons can move on the surface of the molecule, but they can't move between the molecules. So I can't get electrons from here that are able to get across to the other molecule over here. They're stuck on this surface, so they're poor conductors. Get as many bullet points as you can into your answer. Remember, when you write this, you write it in sentences, and you'll get some good marks in your response.